Hello and welcome. My name is Victoria, and today we will be looking at the best ways for the United States to prepare for the upcoming influenza season and what kinds of preparations should be made for future seasons. So, today we will be considering historical data from 2009 to 2017 to assess the impact of a population age on influenza deaths and hospitalizations in order to assess staffing needs for each state during the upcoming flu season. I just want to draw your attention to the graph in the corner. It's showing over the age of 65 influenza deaths from the period 2009 to 2017. Now, we can see that there are two at the top which are showing higher rates than the others. I want to just quickly draw your attention to those two. We can see that California in 2017 has 5,510 over the age of 65 influenza deaths, compared to New York in 2017, which has 3,955. The next one to come anywhere close to those two is Florida in 2017 with 2,554 deaths over the age of 65 due to influenza related illnesses. Um, this is going to be a big topic in what we are discussing today, as we can quickly just see here, there is already high amounts of influenza deaths among the age of 65 plus, and we will be investigating this further. One thing I do want you to keep in mind is the two states that I have mentioned there, California and New York, as they will be repeatedly called upon throughout this presentation. So, in order to anticipate where increased staffing levels will be required the most, we need to look at population size within each of the states. As a general rule, if there is higher population levels, there is more likely to be an increased need on demand for services. So, the map here is showing the United States. The darker blues are indicating a higher population level. This map is currently showing all the average from all the years of 2009 to 2017. So as you can see here, California has been highlighted. It has around 39 million as a population level, and also Texas around 27 million, and then New York around 20 million. These are our top highest states for population during this period. So if we use the filter on the side, we can change the year and see if there are any changes in the shades of blue from these states. So we're just going to take a random sample of 2010 and see what, if any, changes have happened. As you can see here, they are all very similar colours with very similar levels of population. Again, if we go to our latest, data from 2017, we can again see a very similar pattern. So this is indicating that there are high population levels within these states, and therefore would be a possibly higher impact in demand on services. So now now we want to consider the impact of age on influenza-related deaths. The bar chart here highlights the significant increases of influenza-related deaths for those over the age of 65 compared to those under the age of 65. If we once again consider California and New York, we know from the previous map they have continuously high population levels. Now we want to see what kind of death rates they have for each group, age group, in terms of influenza deaths. Almost immediately, we can see that there is a significant difference for California between the age groups. Here, it's showing as 47,483 above the age of 65, compared to under 65, which is only 6,519 through the full period of 2009 to 2017. And if we scroll down to New York, we can see that again, this pattern is highlighted. New York, over the age of 65, influenza deaths are at 36,576 compared to under the age of 65 of 4,299. In fact, if we just take a quick look through all of the states, we can see consistently that the age group of 65 plus has more influenza deaths than the age group of 65 of under 65. If we now turn our attention over to the scatter plot, which has a comparison of 65 plus population and mortality rate are for those aged 65 and over. As you can see here, the data is closely aligned with the trend line, indicating a strong correlation between these two variables. There are a few outliers here and here. However, the majority of these data points are very situated on the trend line. Which again indicates that they have a strong correlation between the two, which based on the data that we have been looking at so far is in line with what our hypothesis was. So far, we have found that there is not only a link, but a strong connection between age and influenza death rates. We now need to consider if this equals an increased need in healthcare visits. This scatter plot here is based on the data for healthcare visits for influenza-like symptoms. We can see that the correlation is not quite as pronounced as the previous one. However, there is a moderate correlation based on the trend line and the way that the data points align with it. You can see here that those data points are quite close to the trend line. However, we do have more outliers and more that are not in line with that trend line. Therefore, it has only a moderate correlation. So now we have an established link. Let's now look at the two maps on the right-hand side. The first one is showing the influenza-like symptoms healthcare visits. Again, we are using the dark colours to indicate more visits. And then if we compare this with the one underneath, which is showing 65 plus population with colour, and then over the age of 65, influenza deaths with circles. The larger the circle means the larger the death rate in that state. So once again, let's take California. If we click on California here, it's now showing us on the scatter plot that they are quite closely aligned with the trend line. And also if we look here, the population levels and the influenza death levels are quite high. And we can see here that it's quite a dark blue for the healthcare visits at 300,000 and 300,016 and 588. So we can see that there is a high level of influenza visits while also being a high level of death and population. There is suggesting that there is a connection here. So if we now look at New York, which while less in comparison of visits, it only has 69,794. There is still a similar pattern. We can see here on the scatter plot that they are quite in line with the trend line, these data points. And again, the high population levels and the high death influenza death rate is there. Therefore, the data is showing that the higher the age, higher the population age, it can lead to more healthcare visits from those suffering from influenza-like symptoms. So, what are we going to do with this? We now know that the states with a denser 65 plus population are going to be in greater need for staff during the upcoming influenza season. If we take the two graphs here highlighting the influenza deaths at the top here and at the bottom here is highlighting the over the age of 65 population, both from 2009 to 2017, including 2 years of forecasting, we can see that there is a pattern on these graphs. Um, Here, our top line is California, New York coming in next, and then Florida and Texas. Again, here, underneath at the highest population levels is California, Florida, Texas, and New York. We can see that these states are likely to need more staffing levels throughout this season as opposed to other states with um, lower population ages. So we want to prioritise deploying additional staffs in winter months. We know that through historical patterns that influenza season tends to begin as the colder weather sets in and continues until the warmer weather comes. So those with large populations aged 65 and older, such as California, Florida, New York, and Texas, they will demonstrate a greater demand during this influenza season. We also want to consider age-specified strategies, develop strategies for different age groups with particular emphasis on those over the age of 65, who, as the data has indicated throughout this presentation, are more vulnerable to complications from influenza and potential death. We want to implement preventative strategies such as promoting vaccinations for individuals over the age of 70 over the age of 65, especially in densely populated states. Consider using educational posters and campaigns to raise awareness about disease prevention and encourage healthy practices, ultimately aiming to reduce the overall impact of influenza. We would suggest regular monitoring of population sizes and mortality rates to ensure the data remains current. This proactive approach will allow for an adjustment to strategies and help identify other states that may experience increased need, and then we need to change our plan or how many staff members are going to be there during this season. So we can clearly see that there is a connection between the aging population and those that are currently likely to die from influenza. Thank you for listening today. If there's anything further, we can have a question time, or if you would like to send emails, I am more than happy to respond to that. Have a lovely rest of your day.